So we looked at sort of manipulating statistics and bad ways you can design studies and you can throw off your studies. Now again, some people want to do that on purpose. Other people, most of the time as a researcher, you don't want to do that. But if you're sort of a partisan in one direction on whatever issue it is, then you may want to actually manipulate your sample or leave out some variables, leave out some data and that kind of stuff. So what we're going to do now is talk about, instead of manipulating the actual and screwing up the actual study, we're going to talk about manipulating stats in the way we talk about them. All right? So the way we represent or talk about data can influence what people think about such data, right? And there's a lot of different ways to represent data, and we're going to look at some kind of interesting ways to either, if you want to mislead, mislead. If you don't want to mislead, we can not mislead. All right. Now, one way to manipulate is to choose the central tendency. So this is choosing central tendency. This is sometimes called ambiguous averages. Now, average, we use that word for just meaning mean in this class, but some people will talk about average meaning the median, okay? And so, for instance, in this case, earlier, we had a median that was like 45,000. But the mean was, I think it was 83,500, something like this. Okay? Now look at how much difference there is in salaries if we talk about the number 45,000 versus 83,500. That's a pretty big gap, almost $40,000 worth of gap. And $40,000 is a huge difference in the vast majority of people's salaries. It would be a huge difference in my salary if it jumped by 40,000 or fell by 40,000 for that matter. Although if it's legal, I don't think that my salary could fall by 40,000. Anyways, so my point is a $40,000 jump is a huge difference. So if I'm talking about this group of people and I want to say that they have a big salary collectively, maybe I use the mean. If I want to think of them having a small salary, maybe I use the median, or smaller anyways. All right? And the vast majority of times, just FYI, when you report salaries, you should use the median because it's not thrown off by a really, really high value. So again, if Bill Gates walked into this room with these 5 people, the median wouldn't change by that much, but the mean would change drastically. Okay, so one really, really high observation can pull the mean up a lot, whereas the median, it doesn't pull up a lot. So you'll often see politicians talk about median salary, almost always median salary or median income or something like this. Now another way that kind of messes with the representation of data is something called changing the subject. Okay, changing the subject, it's kind of like the only thing we're doing is we're talking about numbers in a different way. All right? So there's some nice YouTube videos out there that I'll probably post and look at sort of the changing of the subject. But the classical examples of this are using raw numbers versus percentages. All right? If I'm a politician, and I want to say we cut a lot of money out of the budget, I may say I cut $100 million out of the budget. And that sounds like a huge number. In fact, that is a huge number. If you had $100 million, that would be earth-shattering in terms of life changes. But in terms of the federal budget, well, $100 million out of, let's say, a $4 trillion budget is like 0.0025%. So when a politician says we're going to cut $100 million, that's like 0.0025% of maybe an entire budget. And all of a sudden that doesn't seem like it's so huge. In fact, that's a very, very small percentage of the budget. So be wary of these kinds of things. And again, let me state this. It works the other way too. There are times when a politician wants to say, we increased funding for education by $100 million, where it might just be by a really, really small percentage. Or they may say, well, we really only cut 0.0025 out of the budget, if they want it to make it sound small. $100 million if they want to sound it big, right? Want it to sound big. So changing the subject is really, you're talking about a number, and the way you represent it can seem really, really big or really, really small. And either case, you sort of choose the one that you want to. If you want to make it sound really big, use the raw number. If you want to make it sound small, use the percentage. And by the way, this is just out of the budget. It works the other way too. I've heard people, and I'm not saying one way or the other, but I've heard people say, well, only 1% of what was the thing of, let's say, abortions are late term, however you define that. And again, I'm not saying I'm pro or against, I'm just using an example. 1% of abortions are late term. Well, I don't know how many abortions there are in the U.S. actually. I'll pause this and look it up. Alright, so I looked it up. It's about 1.21 million abortions. Now, if only 1% of abortions are late term, that means there are about 12,100 late term abortions. Each year. So if somebody says, only 1% of abortions are late term, to somebody who doesn't like abortions, that 12,000, that's quite a few late term abortions, right? So again, if you're for the ability to have an abortion, then you might use that 1% number. If you're against it, you might use that 12,000 number. All right? And again, you can be for or against. I'm not telling you which way to do this. Now, another way you can mislead is using graphs that aren't really very good. So, for instance, if you have a bar graph, and the bar graph looks like this, all right? Well, if the bar graph started at 80, and let's say this is 85 here at top, that might not be a huge difference, or excuse me, that's not maybe a huge difference, right? So if I said there's two groups, A and B, and 81% of A says they like chocolate ice cream, 85% of B says they like chocolate ice cream, that's not a huge difference, okay? But the way we've drawn the graph, it does make it look like it's a huge difference, okay? If you're drawing a graph and it's a bar graph, you should probably start with 0. And then, if you started at 0, then 81 may look like this and 85 may look like this. And you get a much better representation of the picture. Okay, again, I didn't draw this very well. And there's all kinds of ways to mislead, right? We could have drawn these bars in a lot of different ways that could seem misleading. Also, maybe you could, another way to mislead is to have these categories not mean the same thing. I saw a while back a Facebook post, and there's a bunch of bars like this, and then the last two bars were really low. Okay? And being the statistical minded person that I am, I looked at how all these bars were measured. And sure enough, it looks like they're increasing. And I don't know if this was debt or deficit or something like this. But it had to do with politics of some notion. I forget what they were. So all these bars, well, these were judged by one measurement. And these last two were judged by a totally different measurement. Okay? And so while it made it look like these last two bars were really small, in reality, these last two bars had really nothing to do with these first few. Okay, so it was in dollars, and I forget, this was in spending, and this was in additional spending. Well, if this was in additional spending, and this was in regular spending, well, the additional should be tacked on to the regular to make it look right. All right, so it was a really weird looking graph. So my point is, there's a lot of different ways to mislead, and I've just taken bar graphs here, but you could take any type of graph and mislead in a lot of ways. Now, the last way we can sort of mislead or manipulate the data is how we measure. So if I measure things in different ways. Now, this is very similar to changing the subject, so I want to sort of get the difference, sort of show you the differences, okay? When I say change the subject, I'm talking about the exact same thing, all right? I'm talking about the $100 million versus the 0.0025%. When I say I'm measuring it in different ways, what I'm going to do is I'm going to say, well, let's talk about income. Well, it turns out income can be measured in a lot of different ways. You can measure something called household income. That's the total income that an average household gets, or median income of a household. Or you can measure income of an individual. Now, I've heard an economist, a famous economist, say that if you're talking about household income, it's really not worth it. It's not a good thing. So he was advocating for individual income to be always used when they talk about income. And there's a good reason for that, and I'm not going to get into that. But individual income isn't subject to people moving and whether a household has 3 or 5 or 10 individuals. So individuals' income you can't do those kinds of weird things with. So income can be measured in a lot of different ways. Life expectancy can be measured in a lot of different ways. There are countries who, when they calculate their life expectancy, don't include infants who die within a year. All right? There are countries who include that in their life expectancy. And whether you include that or you don't include that, it's up to you, but you're going to get different numbers in both ways. Okay? A real good example of measuring things in different ways are healthcare rankings. Whoops. You'll often see headlines or news programs say something like the U.S. is ranked, and I'm making up a number, I don't know, 40th out of all countries in healthcare. All right? Well, you should always ask yourself, how did they actually measure healthcare? Because healthcare is a very loosely defined term. Okay? Did they measure it based on things like availability to all? If your healthcare system is available to all, did they rank it on, for instance, the percentage of people who survived certain diseases? Did they rank it on how nice the hospitals were inside? Meaning how clean, how you only have to share one room? Did they kind of put all these things together and come out with some sort of a weird, hybrid system of ranking? Most of the systems are sort of hybrids of all these kinds of things. Okay? But it's important to know that when we say U.S. is ranked 40th in healthcare, are we talking about availability, or are we talking about their survival percentage of breast cancer or testicular cancer? Because the U.S., while availability to everybody might be ranked way low, those who survive certain diseases may be really high. And you have to ask yourself, which things are more important in your ranking system? Is it not being forced to share a room? Is it how many people survive? Is this healthcare available to everybody? Or are hospitals available to everybody equally? And all too often, politicians will just say this first line, not understanding what sort of goes into it. Now, again, I pick on politicians here because they're sort of easy to pick on. They're low-hanging fruit, as some call it. But people do this all the time. You'll see Facebook posts that talk about how horrible either the United States is or how great the United States is in terms of some ranking system. And you often have to ask yourself, well, where did they get that ranking? How did they actually measure things? All of these things. All right? So I hope you've seen there's a lot of different ways to sort of mislead. I've been talking about misleading. But again, when I say mislead, I don't necessarily mean it's on purpose. I just mean it could be misleading. All right? It could be giving a different representation of what either the person telling you wants or the person who's consuming the information wants.